All right, so we're going to introduce the last two trig functions. We're going to graph those. The first one is secant. Remember, this is the reciprocal of cosine, and so you're going to see a lot of cosine in this graph. Then, in fact, we're going to use some of the basic things, like, for example, 2 pi over b. That's the same thing that cosine and sine have always had. A and b are both 1. Notice I didn't write amplitude down because secant doesn't have an amplitude. We're going to draw this exactly like cosine. In fact, I'm going to draw in dotted line, but I'm going to draw cosine as if this were just the cosine of theta. That's exactly what I'm going to do here. And so you can see that I've kind of put down those same exact units, the increment, if you will, on the x-axis. And of course, going up 1, down 1, just like before. We're going to go in and we're going to draw in what we would consider the parent function of cosine, right? Cosine always starts at its top, and it kind of works its way down from the middle and all the way back up to the top, right? So really, this is what I'm keeping in my head as I'm kind of graphing this stuff. So you can see, I'm just going to go and put the dots down along each one. It's always easy to put the dots down first, and then I'm just going to I'm going to adopt this because this is not actually part of the graph. This is giving me a framework to be able to draw in the graph once I get this down. Okay, key things here is that wherever you hit the midline, right, there's 2 places here, we're going to draw vertical asymptotes everywhere you touch the midline. That's going to be true for secant and cosecant. And so once I do that, I want to find all the maximum and minimum points along this graph that I've drawn originally, right? So we got one here, we got one here, and one here. And what you're going to do is you're going to draw these. They're parabolic, sort of. They're not really parabolas, but that's the closest thing you probably know to them. And so we're going to draw those up towards the asymptotes. Notice on the edges, I only drew half of it. I don't have this other asymptote out here. You're welcome to kind of extend it out and draw it that far. I didn't think it was really necessary. What I want to do is I want to have one full period of this, right? So I want a full parabola above it and one down below it. And so here we kind of got one half here, one half there, one hole down at the bottom. That gives me the whole part. And that's secant, right? If you can graph cosine, then you can graph secant. And I mean, when it gets complicated, like the next graph, this is secant with all the different changes to it, right? So you can see here we have amplitude, or well, we have A, we have B, H, and K. If we label all of those pieces, then what we will see is when we find out all of the pieces like amplitude, period, phase shift, and vertical shift, there's only one difference with sine and cosine. With sine and cosine, you had definitely just, well, you had amplitude and period. In this one, we only have, we don't have amplitude. I've got a 2, but I do not have amplitude, right? So keep that in mind as you're looking at these things. Let me move this out of the way. Actually, I'm going to move down here. And so here we have period, 2 pi over b. That's easy. My phase shift is the same as h divided by b. And vertical shift is always k. So no change there. What we're going to do next is we're going to draw out our axes, and we're going to kind of keep going with this idea. Okay, so what I've done here is I've given myself a first mark. I'm going to go ahead, I'm going to add I'm going to add another one eventually. My beginning point is going to be my phase shift, just like it always has been with sine and cosine. So this is a good review for you if you can't remember that. And so I'm going to take my period, I'm going to divide it by 4 to get the increment. And we're going to see that. We're going to start here. We're going to add pi over 2 plus pi over 2. It's really nice. Or pi over 4. These are like quarters. So 50 cents plus a quarter, 75, then $1, then so forth. And I can create these. And if I didn't have a common denominator, which in this case it's kind of easy, I would just find that common denominator and I would keep adding just like we always have. I'm going to take my vertical shift, right? That's this mark here. We're going to add that and add my a value to it, subtract it. So we have my a of 2, so I go up 2, down 2. And since this is secant, I'm going to start drawing in my cosine function, starting at the top, maximum, and kind of working my way around. Dotting that line as we kind of go through that function. And then we're going to go back in everywhere I had technically this would be considered 0, but every time I hit the midline, I'm going to draw in a vertical asymptote. and then we go in and we draw our curves back in the places where we find our min and our maxes. I mean, I'm not going to make this more complicated than it is. If you know how to graph sine and cosine, then you pretty much already know how to graph secant and cosecant. And here you go, put in my curves, finish that out, and that's how you draw secant. And it doesn't really get more complicated than this, other than maybe throwing in a reflection or something. The other one is called cosecant. This is the reciprocal of sine, so keep that in mind. We have a period of 2 pi. We have a and b of 1 each. No phase shift or vertical shift here. I'm going to draw this just like we do with the secant. I'm going to draw my parent function with the foundation or the framework of sine of x. So I'm going to go ahead and I'm going to add those different values in that we've always worked with. We're going to be starting here at the origin with sine. We're going to add our a value above and below. I'm going to go ahead and I'm going to put my dots in for sine of x all the way down. Now notice this time when I draw in my asymptotes, remember the thing I said was that if you're going to be drawing in asymptotes, you're looking for every place it touches the midline. Notice here there's 3 of them, right? So I'm going to add an asymptote at the beginning, the middle, and the end. So 1, 2, and 3. And then I'm just going to draw on those curves like I did. I'm going to find the max and the min values. Everywhere they occur, I'm going to draw those parabolic shapes, or almost parabolic shapes, in. And make sure that when you draw these in, you don't cross these asymptotes. That's a big deal. That's what those are there for. They're boundaries. Keep them separate. Don't try to cross over them. And that's cosecant. Now, when we graph cosecant as a fairly complicated graph, here again, I'm not going to make this harder than it needs to be. This is essentially graphing sine, and if you can graph sine, you can graph this. And so what you'll notice is we're just going to kind of go through the rule. We have here a -3. Notice the negative. That is a reflection. So I don't have amplitude here, but I'm going to make myself a note to remind myself to actually reflect this over the x-axis or draw this thing upside down. We have a b of 3. My period is going to be 2 pi over 3. Phase shift is going to be negative pi over 2 divided by 3. So I'm going to have to do a little bit of fraction work here, multiply that by 1/3, and we're going to get a negative pi over 6 as a phase shift. The one thing I don't have left is, is to find my increment, right? So we're going to start with a horizontal value. We always start with our phase shift. That's great, but where do I go from there? I need the increment. So I go back up to my period. I'm going to have to divide this by 4, so that's going to be some more fractional stuff. 2 pi over 3 divided by 4. Take that 4 over 1, multiply by 1/4. We notice we get some reduction here. 2 goes into 2 once, 4 twice. So we're going to get pi over 2 times 3 is 6. Right? So I'm going to be starting at negative pi over 6. I'm going to be adding pi over 6 each time. It's kind of nice. It was already a 6, so I didn't have to find any common numbers here. So sometimes it actually does work out easily. And I'm adding that, so this would be 1/6, then 2/6, which reduces to 1/3. 2/6 plus 1 more 6 would give me a 3/6 or a pi over 2, and that's my 5 different marks. There's 0, so I'm going to add in that y-axis, and we're going to kind of go back over to our vertical shift, and we're going to add that to our a value. I'm not really concerned about the negative sign right now. I'm going to take 1, I'm going to add 3 to it to get 4, and take 1 and subtract 3 from it to get our -2 down at the bottom. What the negative is going to do is when I go to put in my points to draw this curve or whatever, then I'm going to be making sure I'm going to draw it upside down. So we're going to start here, but rather than going up to the +4 for my sine function, we're going to go down to the bottom and then back up to the midline here and here. Because it was negative, I'm going to do it that way. We're going to add in our dotted line. This is going to be our framework. Remember, we're going to add in the asymptotes at the midline here, where my dotted line crosses over that midline. So you can add in those asymptotes and then draw your curve, and you are essentially done, right? So here's my asymptotes for first one. You're always going to have 3 asymptotes with cosecant. You'll always have 2 asymptotes, or is it 2? 4 asymptotes. I can't remember. You'll have 2 asymptotes with secant. Yeah, it'll be 2. All right, so we end up getting both pieces here, and that's the whole graph. Hope this helps. We'll see you guys next time.